Yes, dear students, welcome to another presentation. In today's presentation, this is the lecture number 5 under module number 1, right? So, module number 1 is nothing but exactly unit number 1 of your JEE physics syllabus, right? Module number 1 refers to the unit number 1 as per our JEE physics syllabus as per JEE main. Okay, under which this is the lecture number 5, and we are discussing about the dimensional analysis, right? Since last presentations, few presentations, we are discussing about the dimensional analysis, which is one of the very important and fundamental topic as far as our JEE physics is concerned. And in previous presentations we have seen some definitions, and then even we have solved one problem in a previous presentation. In today's presentation, I would like to explain you one important, I mean, uh, example, one important problem, okay, which is asked in earlier JE mains examination. This is normally called as PYQ, PYQ, right? Nothing but PYQ, nothing but previous year question. PYQ nothing but previous year questions. So in this, it is asked that find out the dimensional formulas. Listen carefully. Find out the dimensional. What is that? Find out the dimensional formulas. Find out the dimensional formulas for the constants. For the constants for the constants in the given expression, in the given velocity expressions, in the given uh, in the given velocity expression, velocity, right? Velocity expression. So one expression has been given, that is nothing but velocity expression. V is equal to something has given, right? I will write you here for your sake, right? So the velocity expression has been given. In that velocity expression we have certain constants. For those constants, it is being asked for us to find out the dimensional formula. What is the dimensional formula? What is the expression given here? I will write that expression for you, right? So the given velocity expression is nothing but, so here in this example, right? So the given velocity expression directly I will write here. V is equal to, it is A into small a into t square. A into t square plus B into t by, it is C, capital C plus t, small t. This is the given expression, right? Small v is equal to A into t square plus B into t by C plus t. This is the given velocity expression, right? So the left side is nothing but v. This is our LHS part, remember, right? This entire is your RHS part, right hand side part. The entire, the total is called as the right side part, as well as V is nothing but the left side part, left hand side part, left hand side, right? So what is this V actually? This V is nothing but velocity. Therefore, as in the given expression, velocity is equal to something has been given. Nothing but what? The second other side of the quantity, whatever it is there, that must be equal to the left side. Therefore, left side is given velocity. Therefore, the the right side is also equals to the same amount of velocity. Nothing but this is also equivalent of this velocity. Okay, this is nothing but equivalent to the velocity. Therefore, velocity is equal to velocity, right? That is what the likewise we have to understand. Now, if you see on the right hand side, a into t square. What is a? Small a. This is called as small a. T, nothing but however, it is t only, time square. And similarly, what is b? B is the constant. A is constant, b is constant, c is constant. Whereas the velocity expression is given with respect to the time actually. The velocity expression is given with respect to time, right? It contains certain constants A, B, C. For this A, B, C, we need to find out the dimensional formulas. We need to find out the dimensional formulas. Well, very good. Then, how the dimensional formula will be calculated? How it is? How it can be found out? Right? Very, very simple. There is nothing difficult. So, I'm going to solve this expression, this problem for you. Now, the solution part. The solution part. Students, first of all, we should know we should know the formula for the velocity. So we know that velocity, what is that? Velocity small v. What is the definition of velocity? Velocity is nothing but change in distance, that is delta x by delta t. Remember that. Okay, change in distance, change in distance or change in time, nothing but this is called as displacement. Otherwise you can write it as displacement. What is that? Displacement by time. Displacement, therefore delta x by delta t, change in the distance, incremental change in the distance by the incremental change in the time. Therefore this is the distance, nothing but, okay, nothing but displacement only. Displacement is nothing but the difference in the distance. Okay, the difference in the distance is called as the displacement, whereas delta t is the time, obviously. So the displacement is measured in what? That in meters, is it not? Therefore the velocity, therefore the velocity v is equal to, it is dx by dt, and x is the distance. X is the distance, therefore difference of x is also distance. Distance is measured in meters, right? Distance is measured in meters by the time is measured in seconds. Following, the time is measured in seconds. Therefore the meters, what is the dimension for meter? M. Meters is the length. Meters is measured in length, therefore length, L. L is the dimension. L is the dimension. What is the second? Second is the unit. Meters and second are the units. Meter is the unit for the distance. Okay, but what is the dimension? That is the dimension is the L. L is the dimension. And what is the second? Second is the unit of time, but it is measured, its dimension is T. L by T. Therefore, V is equal to L T power. This T you can take in the numerator part, T power minus 1. Shall I write like that? Therefore, small v is equal to LT inverse. So this denominator part you can take to the numerator side. Therefore, that becomes T power minus 1. Therefore, L into T power minus 1. That is the dimension of velocity. That is the dimension of velocity. We have to remember. Clear? Dimension of velocity. Now we have to find out the dimension formula A, B, and C. You got it? You got it. V is equal to L into 2 inverse is nothing but the dimension formula for the velocity. Okay. Then coming to the constant A, how this can be obtained. So listen carefully here. Remember here, nothing but what? So here, this is the first term. AT square is the first term on the right hand side. Whatever the RHS part, in this RHS part, AT square is the first term. First term plus B into T by C plus T. This entire is the second term. Therefore, nothing but what actually your velocity V is sum of two terms, 1 plus 2. Shall I write like that? So your velocity v is equal to sum of two terms. So this is first term, the term 1, and this is the term 2, second term. Therefore, sum of two terms is equal to v. Therefore, in the first term, nothing but 8 square, nothing but what actually, what exactly? Therefore, nothing but what? Nothing but what? According to the principle of homogeneity. We have to remember this principle. It is principle of homogeneity. Homo homogeneity. What is the principle of homogeneity? According to the principle of homogeneity, so the sum of individual terms added on the right side must be equal to the left side. The dimensions of the sum of individual terms added either side must be equal, otherwise. Okay, that is the principle of homogeneity, right? In simple way, I can write that AT square must be equal to V. Your BT by C plus T, the second term also equal to the V. So this AT square is equal to V. Similarly, plus BT by C plus T is also equal to V. Therefore, individually, first what I can do, you equate V is equal to AT square first. You equate V is equal to AT square. Take the first term, you equate this AT square is equal to V. And in the second step, equate B into T by C plus T is equal to V. Right? You got it? Now, by doing like that, what we will get here is that V is equal to A into T square. A into T square. Is it not? What is A actually? What is V? What is the dimension formula for V? It is L into T power minus 1. Just now we have seen. Is it not? Is it not? So what is the dimensional formula for V? L into T power minus 1. And what is A actually? A is the constant. You can write like this. A is the constant. Then what is T? T is the time. T is the time. What is the dimension for time? Capital T. Therefore, how much? It is square. Therefore, T square. Therefore, L T inverse is equal to A into T square. Okay. This you can write A into T square. Therefore, from this, LT inverse is equal to A into T square. Therefore, from here, A is equal to what? From here, A is equal to what? How you can write? A is equal to, bring this T square here, left side. Then A is equal to, you can write like this. LT inverse, what you can write? L into T inverse is equal to A into T square. This implies, you can put A there itself. Bring that t square to left side, L power t power minus 3, because t square comes in the denominator part here. Therefore, if you bring the denominator to the upper, therefore it is t power minus 2. Therefore, t power minus 1 is there, and t power minus 2, therefore t power minus 3. Therefore, A is equal to L t power minus 3, right? Or otherwise, this can be written as in general, normally in the dimension formula, M L T will be written in the order. Therefore, M. So there is no M here. Therefore, you can write M power 0. M power 0, because M power 0. Okay. So there is no mass value here. But for the sake, you can write like that, M power 0, and it is L. What is the power? 1. L power 1. So nothing is given. Only L is there. Nothing but power is 1. L power 1 and T power minus 3. We got it? Got it. Therefore, A is equal to this L into T power minus 3, and the same can be written as M power 0. M power 0, because M is not there. M is not there. However, M power 0 is 1. Okay, M power 0 is 1. Therefore, you can write like this, nothing wrong in that. Therefore, M power 0, L power 1, T power minus. This is the dimensional formula for A. Got it? That is the dimensional formula for A. And coming to the second term, the second term. Now you can equate the second term. What is the second term? This B into T by C plus T. This entire is the second term. Therefore, in the second step, what I can do, this V is equal to, this V is must be okay. We must equate it to this second term, B into T by C plus T. This is equal to, remember that in the denominator part, C plus T is given. C plus T is given. Remember that. So the C is the constant. This constant will also shares the same dimension as this time will have. The dimension of this time t will be shared by the C only. Therefore, the total C plus T, therefore, plus C plus T, you can write T only as the dimensional formula. Because C is the constant, this constant we are directly adding to the time t only. Therefore the combined effect, the overall effect, the overall dimension is t itself. T itself, remember that, t itself. Therefore now what is v actually? What is the dimension formula for v? This implies it is l power t minus 1 for v. L power t power minus 1, and it is b. What is time actually? It is t only, is it not? B into t. B is the constant. That is why I have written as it is. T is the time actually. The dimension of time t is equal to capital T by what is c plus t? What is the dimension of c plus t? It is t only. It is t only. Getting? Therefore, here time by time. Okay. In numerator you will have time. Denominator will have time. Time. Okay. This time will be cancels out. Only b remains here. Therefore, b is equal to what is that? B is equal to your, what you will get? Thus, B is equal to LT inverse. B is equal to LT inverse only. Is it not? B is equal to, okay, LT inverse. That's it. That's it. That's it. Therefore, what you got here? Therefore, this implies the velocity formula is equal to L power minus T, LT inverse. B is the constant. This is time by this also time. Therefore, that time, this time will cancel. B is equal to L T. Therefore, B is equal to L power T power minus 1. Therefore, you can write B, the dimension formula, M power 0, L power 1, T power minus 1. That you have to write. It is L power 1, T power minus 1, M equal to M power 0. That is what. Okay. Okay. Therefore, this is what the dimension formula for B. And similarly, for C plus T, C plus T. C plus T is nothing but what? So your C is also equal to time only. So for C, it equal to time only. T. T is the dimension formula. Likewise. Got it? So likewise, for any given formula, for any given equation, it will be asked in the examination that find out the dimension formula for the given constants. One expression will be given. In that expression, some constant will also given. For those constants, it will be asked to find out the dimension formula. Likewise, you have to find out. I hope you understood this. And in the next presentation, we will solve some more PYQs, previous year questions, which are asked in the JEE main examinations from this dimension analysis. Right? Thank you. Thank you very much.